Hey guys, just trying a few different things here, but I think we should be good to go. Let me just see you. Sweet, that sounds all good. So, what we're going to be covering in this particular tutorial is we're going to be looking at 2019 question one. Um, I was supposed to make all these as full-on videos, but I've just been really struggling with time just with my kind of training for, yeah, just work's been kind of busy. So that's why I've been running the live streams where I've just been going through the exam papers. Some people have kind of mentioned, some people have asked me to do some questions. So if you do have questions, you could always just drop it to my email is the best one because generally the photos kind of play up a bit on Instagram and on Facebook is not too bad, but email is the best option. So, in saying that, we'll get straight into this particular paper, and I'm just going to focus on question one today. And then, depending on how much time we have, we can actually go through a couple of the questions that's been sent to me. I do apologize if I lose my voice because yesterday after my the 2-hour calculus tutorial, I kind of started losing my voice. But anyway, that's all right. Let's just get started, all right? So we go through the first question here. Let me just get rid of the rule lines. Cool, we're good. So this is going back from our first question. What I've discovered with geometric reasoning paper is that there tends to be a lot more kind of merit questions than achieved. Like I'm looking at this particular paper. They have 4 questions for question one, and it's basically 2 merit questions and 2 excellence questions. All right, so it's almost like they just don't have achieved questions at all that I can see. Like, yeah, it's like 1 or 2 achieved questions, but mainly they go with straight up merit questions or excellence questions. So, having a look at this first question here. What I might do is I might give you guys like, just because this is this is an exam paper that I'm actually going through, I might give you guys like just a couple of minutes just to have a look through the question and have a go by yourself, and then I'll go through the answer. As always, yeah, I'll give you guys some time to just look through it. So what happens with these types of questions is that really important is that, even if you don't know the exact rules that you have to actually use, getting just an idea of what the answer is, you could potentially get an achieved for this, all right? So, yeah, so what we're going to have to do is we kind of have to prove some of the angles. So like even before that, what you could do is, what I generally tend to do is I kind of start doing this just to give me an idea. So what I do is I've got 78 here, which is because EDC is 78, and because they're parallel angles, this is also going to be 78 parallel lines. They're going to be 78 degrees, and which also means this right here is going to be 78 degrees because they're corresponding angles in a parallel line. So I guess that's the first thing I'm going to kind of mention, that angle ABG equals 78 degrees. And the reason I'm going to write is corresponding angles are equal. Now, a lot of people have actually asked me, like, look, is there like shortcuts for this? And yes, there's shortcuts. You could, in fact, I find the shortcuts sometimes a bit challenging, so I just write the full reason as it is. I just go corresponding angles are equal for parallel lines. And Yeah, so the parallel one, you can actually put two lines like that. Sometimes you might see it like two straight lines like this as well. All right, so that's the first kind of step that we need. And then the second step is actually trying to figure out what x is. So in this case, angle AGB equals 180 take away 78 take away 44, which is going to give us 58 degrees. And that one, angles in a triangle. So angles in a triangle, add to 180. All right, nice little kind of like easy question to start off the paper with. Surprisingly, you actually get merit for this, and correct angle found with at least one valid reason. So you got to get the angle correct, and you also need to get one of the reasons correct to get a merit grade. All right, so if you just put 58 by itself, just writing answer only is going to get you an achieved. All right, so can the reason be congruent triangles? Interesting reason. You would have, well, I'm looking at the congruent triangles. You could potentially say that they are similar triangles. Yes, I see where you're coming from, Henry, so it might actually work. But yeah, it's, yeah, you could actually say it's because it's similar triangles where they share a same kind of common side. Yeah, it is possible, yeah. Yeah, well, you couldn't use fully use similar triangles, Reem. We kind of just have to kind of mention that what the how we got that 78 degrees first. So before you get to that 58. But I guess if you say the answer is 58 and your valid reason is because it's similar triangles, therefore ABG is 78, I don't see why not. Cool. Can we move on to the next question? Yeah, corresponding angles is easier, yeah. We'll go through that, I think, in question C, Eric. So just be patient. Yep, okay, cool. That's good enough for me. One person has said we can actually move on. So we are going to move on for the next question. So this is question B here. And this question also happens to be a merit question. So what are they asking in this question? So same sale again that we're working with. We've got AK, which is 2.8. That's already mentioned. Like, so that's there. And then KH is 1.2, which is given there. Angle AKE is 90 degrees. So basically they're talking about this angle here, which is 90 degrees. And you've got to find the area of the sail. Okay, so how are we going to actually go about doing this? Now, sometimes what might help in this case is that, again, if you get a question like this and you've got no idea of how to start it, I would actually say to people is like, just get into the habit of just writing down all the information you know from the question, and then it should help you out. So we're actually looking for the area of AHE. So we are looking for this particular triangle's area. All right. Now what I'm going to do is we're going to, yep, you're on the right track there, Roland. What we're going to do is we're going to flip that triangle a bit. So we're going to flip it like this, where this is HKA. All right, so we know that this was 2.8 meters and this is 1.2 meters. And I guess we kind of need to figure out the height. The height of this is, which is the sail. So this is the height right there. That's what we're trying to figure out. we don't actually have any of the distance AE or AH. So what we can do though is we could actually use this angle here, because that angle there is equal to 46 degrees, because we got a 90-degree angle there. So we're going to change that to 46 degrees. Quinn, the reason I flipped it is because I wanted to find the area of a triangle, and it's half times base times height. So just to kind of make that this part right here to be the base, and then this part right here to be the height of the triangle. So that's a really good question there. And how do we know that it's a 90-degree angle? If you have a look at this point right here, where it says the mast AKH is vertical, if anything is vertical, then it's going in at 90 degrees. So that basically is telling you that that line there is at 90 degrees. All right, so now that we've got this, we can actually figure out what the height is. And for the height, what we're going to do is we're just going to use the small triangle here, which is 2.8 and 46 degrees. And we want to actually try and figure out this. Now, this is going to be opposite. This is going to be adjacent. And so what we've got here is we're going to use tan. So we've got tan of 46 is equal to opposite divided by adjacent. So tan of 46 equals opposite divided by 2.8. So we're going to get 2.8 tan 46 equals opposite. Now, just another kind of quick little note, guys. Why is it 46? Okay. The reason it's 46 is I went 90 minus 44, Lena, to get that 46. Yeah, just going back to the calculator, guys. One thing that kind of people forget to do sometimes, and you guys are level 1, this is probably the first time you're going to actually be doing this kind of exam where you're going to go and reset your calculator. Now, really important is this. When you reset your calculator, what happens is the calculator actually goes into radians mode. All right? So every time you start your calculator, I'll show you guys what I mean by. If you click on Shift Setup, and what will happen is the angle, right now it's actually set in radians. All right? So that basically means that, remember that when you're working in the question, you're actually working with 46 degrees. So it's really important that you change your calculator from radians to degrees the moment you go into your exam. All right? Because in your exam, they'll ask you to reset the calculators. When you reset the calculator is going to go back to radians. So make sure you actually set it to degrees before you start doing any sort of trig. So I'm going to change it back to degrees. Once I change it to degrees, now I'm going to go 2.8 multiplied by tan 46. So that's giving me 2.899. So the opposite is equal to 2.899. So I'm going to put that here as 2.899. So the area is equal to half times base times height, which is half. Now the base is 4, because I've got 2.8 plus 1.2 multiplied by 2.899. Now I'm going to leave this 2.899 here, and I'm going to multiply it by 4, and I'm going to multiply it by a half. So therefore, I get my area here as 5.799. And it's meter squared, I believe. Yes, it's meter squared. Lucid, I've done question 1 in the last week's tutorial. I'll try and get it done, man. I've just been super busy at work. Crazy busy at work. But anyway, look, I'm going to come back to this question. So grades wise, what are you going to get for grades? Correct calculation, height of triangle. So if you figure out the height of triangle, you could get an achieved Or if you get the wrong answer for the area of the triangle, but your working out is all correct, you could get an achieved for that as well. But if you get the full correct answer, then you actually get a merit grade for it. Sure. So Emily, if you want to change your graphics calculator from degrees to radians, just go into your normal menu and just click on Shift and click on Shift menu, which is the Shift. It takes you to the Setup button, and then just move the cursor down all the way down to Angle. And if it's in radians, it'll be F2. You want to change it back to degrees, you want to press F1, and that changes it back to degrees. Eric, check out I think I pretty much put the schedule out for the tutorials on all my social media, so have a look there, man. Bhargav, 1 over 2 is 0.5. What's the 4 for? The base, if you guys look at the base, it's actually 2.8 plus 1.2, which is equal to 4. So I got the base from here. The 4 is actually 2.8 plus 1.2, which is 4. All right. Yep, no worries, Emily. All right, can we move on to the next question, or are we happy with this? Or need some questions? Cool, moving on. I know people have been bugging me about the tables, equations, and graphs paper. I, as I said, I've just been like swamped at work, and that's why I'm doing these as live streams at the moment. Yeah, just work has been a bit crazy. So I'll try my best to get it in the next few days, but yeah, I've got some pretty full-on days at work at the moment. Okay, so those people that were asking me about similar triangles earlier. All right, so with this particular question, we are going to have to use a little bit of similar triangles. As always, I'm going to kind of give you guys a couple of minutes just to have a read through the question, and then after that we can actually try and work it through. And yes, I'll show you guys a couple of ways of doing this, so that you've got a couple of different things when it comes to similar triangles. And what do you go? Short triangles are similar. All right, so let's go through this question here. Now, there's no level 2 geometric reasoning. It's level 2 trig, which is an internal. But having similar triangles is actually very useful for level 3 calculus. So if you're planning to do calculus at level 3, I'd strongly recommend understanding how to do similar triangles. All right, guys. So let's go through this particular question here. All right. So what we've got here is we've basically got two triangles. I mean, we're looking at these triangles and we know we're working with similar triangles. The reason we're working with similar triangles is because the first kind of idea is that they both have the same angles, and the second thing that's actually kind of the idea is that they're both isosceles triangles. All right, because of those two lines there, it basically tells us that they're both isosceles triangles. So kind of going from here, we've got so many ways in which we can actually answer this question, because the question is actually saying for the canoes to sail as fast, the total area of both of these triangles has got to be 14 meters squared. So we're basically looking for the area of both of these triangles. So what can we do here? We can actually work out the height of triangle P, and then we can use similar triangles to work out height of triangle Q and then put it together. That's one way to do it. The other way to do it is find out what's the ratio in terms of how big is triangle P compared to triangle Q, and then we can do something with the area as well. So the first method that I'm going to do is I'm actually going to work out the area of P, and then I'm going to try and show you guys how that ratio thing works. So to work out the triangle P's height, we've got 6 there and we've got 3.6. So I'm going to split that up into a little right angle triangle like this, which means that there is going to be 1.8 and 1.8 on the other side, but I don't really care about the other side, because all I'm going to need to use is I'm going to use Pythagoras to try and figure out the missing side, because remember that we've got a squared plus b squared is hypotenuse squared. So basically what we have, we're going to put this as x for now, as the height, because hypotenuse is also with h, so I don't want to get you guys confused. So I'm going to put down as x squared plus 1.8 squared equals to 6 squared. So x squared is equal to 6 squared minus 1.8 squared. And the biggest thing people forget to do is once they do this, they actually forget to take the square root sign. So what you want to do is you want to put a square root sign straight away and put everything in the brackets after that. So you've got 6 squared minus 1.8 squared. So that's giving me a height of 5.72. Now, just doing this right here is going to get you an achieved grade to start off with. All right, so once we have that as a grade, calculation of area of either sail P or Q. Okay, that's fine. So next step is we're going to actually work out the area of triangle P. So triangle P's area, so we're going to write something like this. Area of P equals half times base times height. So our base is 3.6 and our height is 5.72. So once again, you notice that I haven't actually moved my calculator. I've just left it at that 5.72, and I'm going to multiply it with 3.6, and I'm going to multiply it by a half. So when I do this, I get an area of 10.303. Meter squared of either sail P or sail Q. And according to this paper, if you calculate the area of P, you're actually going to get a merit for this. All right, so you know it was really interesting because we had 2 questions where we had to find area. One of them we had to use trig to find area, and the second one we had to use Pythagoras. 5.72. Bell, it really shouldn't matter, but one of the things about what I recommend students to do is that when you write your answer in the paper, you can write it as 5.72, but when you're actually using your calculator, just, you know, don't get rid of that answer, just leave it there so that you don't get like rounding errors. So I usually just leave it as 5.72, but when it comes to the calculator, I'll make sure that I'm actually using the full answer rather than just 5.72. 10.269, 296. Yeah, as I said to you guys, I know some of you guys are putting 10 point. Is it because you guys use 5.72? Let me check. Yeah, so 10.296. Yeah, it doesn't really say on the schedule about rounding yet, but like I'm just worried like something like this. For example, when you find the area of Q, and if it's like 3.6 6 or something like that, like that's going to make a difference, because this particular question, it says that your area needs to be greater than 14. So I would really be careful with rounding error, with rounding. So I would actually use that full answer. But anyway, we still got to work out the area of Q. Now, here's what I want to show you guys, the couple of shortcuts with similar triangles. And this only works with this. It works with the ratio. What I mean by the ratio is this. If you look at triangle P and triangle Q, what is a triple A rule? Geez, I've not heard of that. Doesn't say about proving it. Okay, so because I can see that these triangles are similar, and I've got 3.6 and 1.44, what I could actually do is I can just go 3.6 divided by 1.44. All right, I'm actually taking the base of those two triangles, and I'm going to go 3.66 divided by 1.44. And as you guys can see, it is a really weird ratio right now. Did I go 3.6 or 3.66? Oops, 3.6. Sorry, let's try that again. 3.6 divided by 1.44. Okay, that's much better. So the ratio, yeah, I haven't heard of this. I'm looking at the answer schedule, and they've got this thing called by considering the AAA rule. Similar triangles. I mean, I do it differently. Oh, triangle similarity test. That's interesting. So you actually try and prove that all the interior angles in one triangle are the same as the other one. There we go. Yeah, angle. Sorry, Aryan, yeah. Anyway, where were we at? So going back to this part right here. Now we actually went the side of the P divided by Q equals 2.5. Now going back to the AAA rule, because remember that this angle here was Z, this was given as Z. And because they're isosceles triangle, you can actually rewrite this as, what would it be? Those two angles would be the same. So that's going to be 180 minus Z over 2. This one is also going to be 180 minus Z over 2. So because of those two, you can kind of just write it up real quickly. And that just shows that it's similar triangles. But anyway, let's go back to the ratio. So the ratio we found by dividing 3.6 by 1.44. So that gives us a ratio of 2.5. So at this point, what you can do is, if you think about it, right, your triangle, P's triangle, is being divided by 2.5, a ratio of 2.5, to get the side of the base of triangle Q. So, however, when you do area, you can't actually just divide by 2.5. You've got to divide it by 2.5 squared. And so this is just something that you guys need to know. So when you're going like side to side, like one side to the other side, you actually divide by 2.5 because that's the ratio for each side. But when it comes to area, you have to go divided by 2.5 squared. And again, if you get to volume later on, but for some reason you actually work with volume, then what happens is you have to divide by 2.5 to the power of 3. All right, and I'll quickly show you guys why that happens very shortly. But let's just get this question out of the way. So we've got 10.303, and we're going to divide it by 2.5 squared. So going back to that answer, we've got 10.303. And we're going to divide by 2.5 squared. Basically, that gives us 1.648, which is the area of Q. Yeah, just I know that side divided area divided by the ratio squared volume. I'll show you guys why that is, all right? Because it's really hard to kind of conceptualize when we're just doing a random question. But what I'll do is I'll finish this question and I'll give you guys a bit more explanation of why we square the ratio and yeah, we'll go through it again, Emily. Don't worry about it. All right. I'm just going to finish up this question, guys, because I've got area P and Q. So P plus Q. P's area was 10.303 plus Q's area was 1.648. And when we add them up together, we're getting 11.95. So we can just say, therefore, sales do not satisfy. Why can't we use as 6 as the height? Ultimate, 6 is on the side. It's like, it's not the height. The height is actually going from the ground up, but 6 is actually on the side of the triangle. So we can't actually use 6 as a height. So going back to the final part, so you've got to calculate the total area, which we have. And you also need to write a conclusion that the sales are not of, they don't satisfy the condition. So this part right here is going to get you an excellence. So I'm going to go back to that ratio, why that ratio gets squared and cubed for the area. But before I do that, does anybody have any other questions with question C? Okay, cool. So why do we actually do this whole ratio thing? Why we actually go in squared? So I'm just going to go off to the side a little bit. Okay, so take this here for example. All right. So what we have got here is I'm going to draw up a rectangle here. So with this rectangle, something's not right. We got a problem. My screen just stopped fully working because I'm writing on here, but nothing's popping up. Sorry guys, just got a little bit of tech difficulties here. Yep, you could do that auxiliary. That's another way of doing it as well. Oh no. Oh, there's my triangle is up. We are back in business. Yes, we're back in business. Okay. So, anyway, I was a bit nervous there because mid crash is never a good thing. So we got this triangle right now, and I'm going to put this as base as 5 and height as 2. So watch what happens here. When I actually calculate the area of this, I'm going to get area of base times height, which equals to 10, let's put this as centimeters. So 10 centimeters squared. Now, if I say I want to increase this rectangle by a ratio of 4, okay? So I want to increase by ratio of 4. What's going to happen to this? What's going to happen to the area? Normally, what people actually say is that they look at the area and they go, oh, it's 10 times 4. So the area of the new rectangle is actually 40. Because it's natural for us to think like that. Because when we think about, when we're increasing something by 4 times the side, 4 times its size, we think that actually the area is also going to get multiplied by 4. But check what happens. If I actually increase the rectangle with a ratio of 4, then the base is now 20, because it's 5 times 4 to get 20. And the height is actually 8, which is 2 times 4 to get 8. Yes, that's correct, Roland. So when we increase this rectangle by a ratio of 4, we're increasing its base and also its height. All right. So now if you look at the new area, we're going to get area of the rectangle is actually 20 times 8, which is equal to 160 centimeters squared. Now remember I said that when you are actually taking an area, and remember I said that you've got to multiply by the ratio squared. So if we actually take 10 and we multiply by the ratio squared, we're going to get 10 times 16, which is 160. And that's the same as what we get, what you get before. So that's one of the reasons why when you actually have an area of something, and if you increase it by a ratio, then you've actually got to increase the area by ratio squared. So could this be a question in the exam on a triangle or a square? Well, it could be any shape. Any shape that you take, whether it's a trapezium or a parallelogram, but if you're increasing that by a k size, then your area of it gets multiplied by the ratio squared. Well, if it's not squared ultimate, then you're going to get 10 times 4, which is actually 40. But if you think about it like this rectangle here is, even though we're increasing it by 4, what's going to happen is, how do I put it? 5 times 4. So kind of like this happens. That little yellow rectangle is just that corner piece there. And by increasing it by a ratio of 4, we have to multiply it by 16 because we've got 16 that's there. So it's just trying to understand how it kind of goes 4 this way and also 4 on the height as well. So whatever the shape, you just times. Well, Emma, so whatever the shape, if it's area, you squared. If it's a volume, you cube it. So let me show you guys what I mean by with a cube, right? So if we have 5, 2, I need to have this in a, so maybe not that as 2, so we'll put this as 2, and we'll put that as 3. So if we, that's correct, Lena, yeah. So if we're working with a volume, so a volume in this case is going to be 5 times 3 times 2, which is 30 centimeter cubed. So if we increase by a ratio of 4, then the new shape is going to look like this. This is now going to be 20, this is going to be 8, and this is going to be 12. So the volume of this is now 20 times 8 times 12, which is, just can't be bothered right now, 20 times 12 times 8. That gives a volume of 1920. Basically what that means is this little cube right here is going to fit in like that. So it actually, you've got to cube it, which means you're actually going 30 multiplied by 4 to the power of 3. So when we do that, we're going to get 30 times 4 to the power of 3, and that gives us 1920. So the only thing you guys need to remember is that when you're working with area and you're working with ratios, area doesn't just get multiplied, it actually gets multiplied by the ratio squared. Bell, yes it does, because area of any shape, area is 2-dimensional. So if it's 2 dimensions, then we square it. If it's 3 dimensions, we cube it. So if you're looking at volume of a sphere, And if you're looking at volume of a cube, cuboid, that gets cubed. So anything that's volume that actually gets cubed, any shape that's area gets squared with the ratio. Cool. Can we move on to the next question? All right, guys. Now we come to possibly one of my favorite questions, which is bearings. I love bearings. I'm not gonna lie. No worries, Jam Matthews. All good. How many? Oh, we've got two Emilys. I'm like wondering what's happening there. All right, guys. So this question here, bearings. I know people look at bearings and they go, "Oh, I hate bearings." Um, in all honesty, I'm going to be brutally honest with you guys. If you're comfortable with basic Sokotoa and your trig, then you are pretty much good with bearings. Now, I don't mind spending a bit of time in bearings because, like every year, there's always a bearings question, and if you nail the bearings question, it usually ends up being excellence, which is worth like 8 points easily, or 7 points, sorry, 7 points easily. So, how do we actually go about answering these types of questions? Now, the first thing I'm going to tell you guys is this. I think first kind of idea is this. Bearings, no matter where they start, like if they give you a bearing of 54 degrees, basically that means north is always starts at 0. All right, so this is just a kind of like a little tip before we start. So this right now is 0 degrees. Sometimes they actually put it as 000. And then we've got, and it goes clockwise. That's something you need to remember as well. So clockwise. So if they say a degree of like 0.54, basically that means that this angle here is 54 degrees from north. It always starts from north and it always goes clockwise. So let's have a look at this particular question. All right. So with bearings, a really good idea is you guys will be given like not like, sometimes you're gonna have like a little bit of discrepancies in the angles, but it shouldn't matter with like I would say with diagrams, I just go with rough diagrams. You don't have to like draw like perfectly accurate ones. No one, like the markers are not going to be sitting there with a protractor and measuring the angles you've drawn. So it's just rough ideas. So the most important thing with bearings though, I would say is this. No, have a go through, like, I guess I didn't give you guys time to actually think about reading this question. Fair enough. Give you guys a minute, have a read through the question, and then we'll kind of have a go through it. Actually, maybe I should read it too. Should we start going through the question yet? All right. So could use Pythagoras. No, 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 no. We can't actually use Pythagoras, Jonty, because it's not a 90-degree angle, so we can't actually use it. I'm going to tell you guys this. If you see a bearings question, get some open space, all right? Get some open space in your exam paper, and I'm almost saying this, like, just draw like a big-ass replay, like when I say replay, just copy that diagram into a big empty space, all right? Because trying to work with that in a small space can actually be super, super annoying. So what I'm going to do is I'm going to do this. I'm going to put this as M right now. I want a big space to work with, so I'm going to put this as S, and I've got G somewhere here. All right. So the yep, no worries, Bell. This should be on replay, so you can actually watch it later. So the first thing is from G to S, he goes on a bearing of 54 degrees from G to S. All right. So basically what that means is that north is going to be there, and this angle from G to S, this angle here is going to be 54 degrees. And we also know that this is going to be 448 kilometers. All right, so that was the first bit of information that we took out. The second bit of information is he changed direction from S to M on a bearing of 294. So if he's going on a bearing of 294 degrees, basically that means, I'm going to use a different color here. This angle here, the red angle, is 294 degrees. So far, so good. So the question is actually telling us to find out the distance from G to M. All right, so we're trying to figure out the distance from G to M. So this is what we're looking for, G to M, which is from here to here. All right, now the reason why I asked you guys to draw it into a big shape is we are literally going to create a little grid on top of this diagram. All right. And the way we're going to create this little grid is we're going to create like almost, I need a different colored pen, but like this will make sense. So I'm going to create a triangle here, but like basically I'm creating like a big ass rectangle like this. All right. And I know that when I create this, that's 90, that's 90, that's 90, and that's 90 degrees. Oh, sorry, we're actually looking for the, not the distance, we're actually looking for the bearing. Okay, so we're looking for the bearing from M, bearing of M from G. Let me just double check that. Yeah, so we're basically looking for, this is what we're looking for. We're looking for bearing of M from G. So we're looking for, maybe not red, let's go with a different color. It's all right. So that's the angle that we're actually looking for. Yeah, sorry, Emily, I kind of missed that there. Cool. So here's what are all the things that we're going to need to find out. All right. So what I say is like, what are all the information that you know, and you can either work backwards. So all right, you can actually work backwards and say, what am I looking for? What are all the things I'm going to need? That's one way. Or you can go forwards, which is basically write down all the information you have, and then literally just calculate everything that you want, and then try and work it out. So in my case, what I'm going to do is I'm going to, because I want to save time, I'm going to slowly, methodically work through this. Now, I know that the angle from here, this part to this part, is actually 270 degrees. All right. I know that that's 270 degrees. Basically, I am looking for this angle X, And if I add that to 270, I'm going to get the bearing of M from G. So I've actually got to figure that angle out. Now, to figure that angle out, I basically need two sides. I'm going to need this yellow side, and I'm also going to need the blue side here, because I can actually work out what tan of opposite over adjacent to actually work out the x. All right, so that's there so far. The next thing is how am I going to work the yellow side? The yellow side, to work out the yellow side, I could use the first triangle here and work out the first part of the yellow here. So that's using the first triangle. Then I can work out the second part of the yellow from the second triangle. And I can also work out what the blue part is. But to do that, I might need to work out this side here first. So basically, you just need to work out all four sides, all right, regardless of how you see it. Work out how four sides, and then we can kind of mess around with it. Emily, the reason it's 270 is when you're starting from north, quarter circle is 90, half circle is 180, and then three-quarter circle is going to be 270 degrees. Same with your Inferno. Cool. So now that we got all of this, we're going to start slowly working out each one of those sides. So the first one I'm going to work out is I'm going to work out the green side here. To work out the green side, what I need to do is I'm going to work out this angle, which is 90 minus 54, which gives me 36 degrees. So I'm just going to take this triangle out, where this is 36 degrees and this is 448. Yeah, Jonty, doing a box is just like easy, man. Like just do the box and work out all the sides of the box. Once you work out all the sides of the box, then whatever you want to calculate becomes super easy. So at the moment, I'm going to try and work out the green part of this triangle first. So that is going to be hypotenuse, and this is going to be adjacent. So I've got cos of 36 equals adjacent over hypotenuse. So adjacent is 448 times cos 36. Put that in the calculator. Let's work it out. So that's going to give me 362.444. And what I'm going to do is I'm going to put that straight in my big diagram there. So this measurement here is going to be 362.44. Now I need to work that yellow bit out. To do that, I could use trigonometry or I could use Pythagoras. It doesn't really matter. So I am going to use trig because it is kind of there. So I've got 448, which happens to be hypotenuse. That's going to be opposite. So I've got sine of 36 equals opposite over hypotenuse. So opposite is equal to 448 times sine 36. So 448 times sine 36 gives me 263.33. So now I'm going to put that as this distance here. Are we okay with what I've actually done so far? Okay, so as I said to you guys before, Safita, we're doing the last question 1D at the moment. So once we got this triangle sorted out, the bottom right corner triangle sorted out, we're now going to go to the top triangle. And I think I missed out one of the measurements, which is 635. So let me just put that there. And we're literally going to repeat the steps. All right. But before we repeat the steps, we need to figure out what that little angle inside of it is. I'm talking about this angle here. So remember we went 294 all the way around. So what we're going to do is we're going to go 360 minus 294, which gives us an angle of 66 degrees. So that angle there is 66 degrees. And again, we're going to move that to the side, and we're going to work out the sides again. So we've got 635, we've got 66 degrees, and let me just put a couple of colors here. So this, we're going to put it as the pink, which is going to be there, and we're also going to put this length here as the orange one. So now we're using trig again to try and work out the orange line and the pink line. Yeah, it really is, Emily. And like, you can't go wrong with drawing the big rectangle, because if you draw the big rectangle, I think finding half the stuff, you're actually going to get a merit for it. This is 2019 paper, last year's paper. Benjamin, which angle are you talking about? Are you talking about the 66 degrees? Now, 66 degrees, bearings questions, normally they don't ask you to show any kind of working. You can just straight away just throw the angles in and just start working out straight away with it. So I'm going to now work out the pink and the orange for this. So what I've got here is, this is going to be hypotenuse, that's going to be opposite, adjacent. And again, I'm just using trigonometry, all right? So I want to work out adjacent first. So cos is cos of 66 is adjacent over hypotenuse. So adjacent is equal to 635 cos 66. Which gives us 258.27 or 28. That's this side right here. I'm going to put it as 258.28. Actually, I should actually put that in my big rectangle. 258.28 kilometer. And then I'm going to use sine now to work out the orange one. So sine of 66 is opposite over hypotenuse. So opposite is equal to 635 sine 66. And the opposite is 580.10. So that's the orange part. So I'm going to put that as 580.10 kilometers. Okay, go find somewhere else to spam. Sorry, Benjamin, you can just write the 66 there without having to worry about having to actually worry about any kind of working, man. So it's all fine. What else am I missing? Now, basically, I do sleep. They should have covered bearings. Yes, Emma, there is like a in my playlist, I'll show you guys later, there's like 3 videos that I created called Bearings 1, 2, 3. They pretty much cover every step from each of the way. Yeah, sorry, Benjamin. Like, it depends which question it is, man. Like with bearings, I generally just say you can just do it straight away. All right, guys, let's just keep going because we're nearly finished with this question. We've got, by drawing it in this big as rectangle, I'm hoping that you guys can actually see how to calculate the yellow on the left-hand side and the light blue at the bottom. Because now you can see that the yellow on the left-hand side is just going to be, that side is going to be 258.28, which is there, plus 263.33. Yes, this live stream will be saved, guys, so you can catch up with it later. So I'm just going to go 258.28 plus 580.10. That gives us 838. Do I want to do it this way? Have I done something? What have I done wrong? Oh, I've added 580.10. Oops, sorry. My mistake. I thought something looked a bit weird. It's 258.28 plus 263.33. Cool, there we go. So we got 521.61. So this measurement, this yellow measurement, is 521.61. Now we've got to actually work out the light blue. So to work out the light blue, what we're going to do is we're going to take the 580 and we're going to subtract it with 362.44. So we've got 580.10 minus 362.44. So 580.10 minus 362.44. So that gives us 217.66. So at this point, we've got the left-hand side triangle, which means we can actually work out what angle X is, because what's going to happen is this becomes opposite, this becomes adjacent. So we can just do that working straight away here and just say tan X equals opposite over adjacent. So X is equal to inverse tan of 521.61 divided by 217.66. Yep. So when we do that, we're just going to go shift tan of 521.61 divided by 217.66. So at this point, we are getting an angle of 67.34 for X. And because we've got that, we can basically say bearing of M from G is 270 degrees plus 67.34 degrees, which gives us 337.34 degrees. And that ends up getting you an excellence question. Right. The reason why I added the 270 is, remember, I'm going to try and do that separately here so you guys can see this. North, the direction of north is actually there. All right, that's where north is. The angle that we found out, which was 67.34, was actually from there to there. So you've got to actually add the remaining 270 degrees that's actually going from the north side. So that means you've got to go from north always, and you've got to add that 270 plus that 67.34 to show the bearing itself. So in terms of merit for this, MX or GX. So to get a merit in this question, you either need to get this part right or this part right. So you can do 360. Now 360 will not work, Lenny, because if you do 360, for 360 what you'll have to do is you'll have to actually work out this angle. Let's call it Y, for example. So that's slightly different, all right? Because yeah, you're offsetting that Y, so which means you got to go, if you're going 360 minus Y, then that's going to give you the full bearing. But in this case, we didn't calculate Y, we actually calculated X. So that's why it's really a good idea to take these questions and, yeah, as Jonty's mentioning, is just redraw it in a big ass box and just work out all the measurements possible. And once you do that, it just works real easily. The idea is that, like, when you draw it as a big box, you can actually see what are all the measurements that you need. So it's a funny odd name, but basically I do sleep. are you setting the geometric reasoning external? If you are, then this stuff will definitely be in it. Like, I think I've not seen a paper without, oh, so if you're not doing it, then that's different, but like, yeah. So guys, any other questions with bearings so far? Or are we happy with it? Okay, so in that case, yeah, I'm like, all I'm gonna say is this, like, I'll share this screen where I've actually created desktop capture. No, go to main recording. I gotta find that one. Where is it? Where is it? Where is it? Where is it? Here we go. So guys, for those of you that wanted to do some extra work on geometric reasoning, especially bearings, if you go down to NCEA level 1, go to geometric reasoning skills, and I think it's right at the bottom there. You can see bearings 1, bearings part 2, and bearings part 3. Those 3 videos should pretty much cover you for any questions with bearings. Small matter, Benjamin. It wouldn't really matter at that point. No, Cat Wolf. I don't actually do probability. I actually like doing the algebra side of things, so I just kind of keep it there. All right, guys. Safita, what do you need help with? Emma, for main things you should know for the exam, like, it depends. I mean, if you're trying to pass the paper, I would say get Pythagoras sussed out and get trigonometry sussed out. And if you know how to do bearings, you can actually skip the whole circle parts and walk out with merit. That's what I would say. But yeah, just kind of go through all those basic rules for geometric reasoning, and make sure you learn bearings, because bearings, I've always seen it pop up in the exams. Never have I not seen bearings. TEG level 1, Safita, I'm gonna try and make a video sometime in the next couple of days, hopefully, and I'll actually go through that video fully. Yes, we'll go through this circle rules in the next session, so we'll actually go through question 2 and 3 in the next time. The final answer, Benjamin, was 337.34. That's a tough one, Harry, because yeah, it's a really tough one for people, ESOL learners as well. My recommendation is, when you do something like this, you can do enough without even understanding a question. Like in bearings, this question here, if I didn't read what that G to M part was and I just did all the calculations, I could still get a merit for it. So no, it doesn't matter, Benjamin, if you're like 0.01 off. All right, guys, I'm going to call it at the moment. Is there any final questions for bearings at the moment? But like I said, when you see bearings question, just create a big rectangle and just work through each of those. Yes, Lena, so I think the question you sent me, pretty much create a big rectangle like this and just work through each of the sides, and then you should be actually able to solve it. Yes, Emma, once I stop the stream, you should be able to find it on my latest videos. Not a problem, Emily. It is what we do. Never. Basically, I do sleep. Never, never, never. Because it's like I'm struggling to just keep up with the algebra stuff at the moment. If I add like probability on my plate, I will, yeah, I'll just be like not getting enough sleep. All right, guys. Cool. That's basically it from me. I think the next tutorial is, when are we doing our next tutorial? We are doing our next tutorial. Where is it? I thought I put it here somewhere. So next level 1 tutorial, at the moment it's scheduled for Sunday. I'll see how I feel on the Thursday because I got a bit of a long day. Um, if it goes well, you might just keep an eye on it for Thursday tutorial. I might just do one, but yeah. Sweet. Level 2, Harry, level 2 is tomorrow. That's level 2 algebra tomorrow. No, I don't, man. There's no payment for this. There's no ads. I don't put any ads. I don't put any, nah, this is just doing it for the, because I can help people, so I'm helping people. Nah, no scam, man. Like, I think it was, it kind of started out helping out my own students first. Um, to be honest, I don't actually teach level 1, level 2, or level 3. I don't actually teach in a NCEA level school anymore. I only teach up to year 10 in my current school. That's all good. It's always nice to hear stories of Infinity Plus One from people. So it is what it is. Anyway, go guys, rest up. And what exam do you suggest us to go through first, John T? I think it depends, John T. Like, are you doing all three, or are you just doing two or one? What are you doing? Night, Benjamin. See you later, man. See, if you're doing geometric reasoning and tables equations in 3 hours, that's a good time. Like, you got an hour and a half for each paper. I would actually say just we'll talk a little bit more about like how you manage your questions so that you can get the maximum grade. Because sometimes it's easy to spend a lot of time in one question and then realize that you can't get it. But then if you miss the merit questions, you might not get grades for that. So we'll talk a little bit more towards closer to the exam on best strategies of approaching the exam paper so you can get like a pretty decent grade. That Emily, for your question, entirely depends on what you're aiming for. At like, to be honest, it's up to you what you're trying to go for. Like, some people are chasing endorsements, so they try and go for like one paper and see if they can try and get an excellence. Some people go for like um, subject endorsements. So, it all depends on the situation. Which topic is that, Safita? Well, I told you, man, I'm going to be doing tables, equations, and graph. Like, Rohan, I wish I could actually give you tips on E for TEG. TEG has been like one of the most trickiest papers in the last kind of couple of years. Last year wasn't too bad. Now, Lena, I would recommend you do TEG for level 2 calculus. It is super useful. Rahul, what level are you talking about? Level 3, I think I did calculus, stats, physics, science, and chemistry. The marking schedule, I will post it right now for you so you can have a look, Benjamin. There's the link for 2019 paper. Joy, you got a grandfather, father, and a son. Now, Safita, that was a link to the answers for Benjamin. If you, it's a different puzzle that I know because two fathers and two sons went fishing, came back with three fish. How's that possible? That's how I knew that puzzle. Safita, for you, I would actually say if you go down to go here, buddy. Like, where is it? Where is it? Where is it? Oh no. If you go to my website, which is actually here, click on the website, and under level 1, you can go to tables, equations, and graphs, go to live tutorials. Like all of my previous tutorials I've done, it's actually there. All right. Or you could go to geometric reasoning. I haven't actually done any tutorials. In fact, this is my first tutorial that I've actually done for geometric reasoning. But all those live streams get saved. But for geometry, I would say, like, just try and get those skills sorted out. I think once you do the skills sorted out, and make sure you cover bearings. Bearings is the big one that's going to pop up. That'll pop up, and that's like a nice excellence question, which usually gets you like 7 points. Geography still gives me nightmares. I did it in level 1. Emma, I think if you know, like, the previous thing that we just did, like, where is it? Where did it go? Where did it go? Like this paper here, we only did 4 questions today. 2 of them were merit questions, and 2 of them were excellence questions. Like, so they're really, geometric reasoning always is like that, like where you have a lot more opportunities to get merit than just achieved. Achieved is like, right, if you just write the answer, you generally get an achieved. Emily, it is, where is it? I'll chuck a link up. There you go. How many questions for achieved? There's a thing called cut score, so you need 8 points. So basically, if you get, how would you have to work? Not sure, Lena. Sometimes they put it, sometimes they don't. Who was it that asked such a? No worries, Richardson. What will get achieved points in a question? Achieve points in a question, like, that, like this question that we did. So remember I told you get merit for solving that yellow line or the blue line. Any of those other calculations that you've done, any single one of those calculations will get you an achieved grade. Aspect, I'm too tired for that right now, man. Benjamin, I think we are scheduled currently for Sunday, but if anything changes, I'll put it up on Instagram on stories, so just keep an eye out there. No worries, Safita. You're welcome. I mean, I'm finished. I'm just kind of chatting to a few people, but I really should go. I'm tired because I want to wake up this tomorrow morning to try and get that tables, equations, and graph out. So yeah, so guys, yes, Joy, you could do that. Highly risky. Geometric reasoning, Jacqueline. Yeah, cool. Anyway, guys, look, I'm going to get going because I got an early morning start, and I've got to get this TEG video out tomorrow, hopefully, just to get it out of the way. It's going to take me about an hour and a half to sort out. So I will catch you guys next time. Keep an eye out on socials. If I come back on Thursday to run a level 1, I might just do like a poll just to see who wants to come, whether it's level 1, 2, or 3 on the Thursday night one. So we'll go with that. Should be good fun. So have a good one, guys. And if you do have any questions, just send it to my email. I start putting them all together and then go through it during the tutorials. All right, cool. See you, and till next time.